Hello everyone. Thank you for being here today. My name is Shane O'Connor and I am joined by my partner Kiet Pham. We are Team SES America and we're here today to talk to you about blankout sign connectivity over a cellular network. So the first question you might find yourself asking is, what is a blankout sign? A blankout sign is a matrix of LEDs within a metal casing that can display various messages to motorists and pedestrians, as you can see with the lane open and lane closed signs here. Our project motivation is twofold. First and foremost is public well-being. Say, for example, there is a major accident on a main roadway. We want to be able to close that roadway quickly and efficiently so as to prevent more accidents and traffic buildup. This brings me to my next point, which is simplifying the sign changing process. As it stands, an operator has to go out and physically change these signs, which is a waste of resources when we can offer an alternative that the operator can use from the safety of their office or their truck, wherever they may be in the field. Our best anticipated outcome is to create a blankout sign system controller capable of monitoring and controlling a sign's status messages and display messages over the cellular network via wireless communication. Some of the key features of this include a retrofittable product that can easily integrate with the existing blankout sign architecture, a user interface that is easy to use regardless of the operator's knowledge of the internal workings of a blankout sign, and finally, the ability to locate signs on a Google map in order to display various status messages such as the sign's location and their current display. Here is a simplified version of our block diagram. In the web application on the client side, we will be using React.js, which is a JavaScript framework, to send data to a web server done in Node.js, to then send it over the internet to the LTE network to be received on our communication system, which consists of a Skywire cellular modem connected to an Arduino microcontroller. Now, I'm going to pass it off to my partner Kit to talk to you about some of the key features in detail.
Thank you, Shane. So today I'd like to talk to you about some of the key features and key accomplishments that we've made thus far, starting first and foremost with the fact that our package is retrofittable. As you can see to my right, these are our two main components that will form our communication system, and which will be housed of every blankout sign in the future. Starting from the top, we have our Skywire cellular modem. What the modem does is it serves as a medium to send and receive messages for the sign. It will be connected to our other main component, which is the Arduino microcontroller. The microcontroller will process the message and then translate them in the way that the sign can understand. Finally, the main characteristic of our package is the fact that it's easily integratable with current blankout sign architecture. This is essential because one of SES America's main services is to retrofit old signs into existing architecture. Next, I'd like to talk to you about our user interface. When designing this, our main core philosophy was to ensure that the website was presentable, elaborate, yet still accessible and user-friendly. As you can see on my right, this is part of our sign manager page, and these buttons correspond with SES America's very own over-the-air protocol, or OTA. What the OTA protocol is it was specifically designed to define messages being sent over the LTE network. So say, for example, I wanted to change the display of my sign to have it display a no right turn. With our GUI here, we would start from the bottom up with the command value. We would press display a message. Going up, since we want a no right turn, we would press no right turn. It would show the lower half of the message. Currently, we are working with 1 byte of data, which is 8 bits. In the future, we want to expand this functionality to actually have 12 bytes of data, so we can actually relay and forward messages. After the entire string is constructed, the user would then be able to validate that they're sending the correct message out to the sign before actually pressing this button. Next, we want to talk about how we're going to locate the signs. We chose to use Google Maps API, and the reason why we're doing this is because Google Maps API has been known to be reliable, yet still simple for the user to interact and navigate with. As you can see in this image to my right, we have our Google Maps API, and the sign will be located with a clickable marker for the user to interact with. And upon doing so, it's going to show a text box for the user. It will show information about the sign such as its name, its latitude and longitude, its serial number, its status of whether or not it's operational, and the current message of the sign being displayed out on the road. With our accomplishments in mind, there are still some key technical challenges that we have to overcome in the next semester in order to achieve our best anticipated outcome. First is the implementation of our message queuing telemetry transport protocol, or MQTT. What it is it's a lightweight, fast, publish and subscribe model. And this is important for us because we don't want the user to be receiving information from every sign out there. We just want them to subscribe to the signs that they want to receive info from, and then have the sign publish the info to the correct users. Next is application deployment. With application deployment, we have to ask ourselves two questions. One, where are we going to host our node server? And two, where are we going to host our database? The answer is, we're planning on using Amazon Web Services EC2 instance to run our application. And what the EC2 instance is, it serves as a processor in the cloud that then allows us to actually run it. And finally, once everything is said and done, we will actually have to start transmitting the messages, as in have the Arduino process the message and translate them, and then have the cellular modem actually receive the messages. And finally, we'd like to thank everybody involved for making this possible this semester. Thank you.